Hey, welcome back. Now that multiple blockchains are syncing up when new blocks are added, let's also make sure that they synchronize on the initial startup of the application. This will make sure that a new instance of the blockchain gets a true state of the historically grown blockchain as soon as it connects to the network. The idea behind this is that the root node will have had the most chances to sync up with the most historically grown in the majority blockchain array that is currently within the network. So it'll be good for a new peer to sync up with that root node's blockchain. To facilitate this, we're going to install a new module called request. So go ahead and kill any running blockchains you might have, and then get ready to install a new module. And this one is called request, and the version in this course is 2.88.0. And go ahead and add the save flag as well, because we want this dependency to be within any version of this project. Cool. So request gives us a nice function that has the ability to send an HTTP GET request. So back in the main index.js file, let's require the request library after express. We're going to grab request by requiring it from the request module. All right, cool. Then in order to make a request to the root node, well, we need to know the root node's address. Let's define the root node address at the top of the file. So right here at the top of the file, let's make a constant called root node address. This is a screen case constant. And then we'll make this by combining http://localhost. And then we're going to insert the default port because the default port is whatever is being used for the root node. So we need to make sure that this default port is declared first. So let's move it above the root node address. And great, we have that root node address now. Now let's define a sync chains function at the bottom of the file, which we can use to make the request to sync the chain with the root node. Right above where we're creating the peer port, let's make a sync chains function. So const sync chains, this is going to be camel cased. We're going to set it to an empty JavaScript arrow function. And in this method, we're going to make our request to the root node's API/blocks endpoint. So let's call the request method. And the input to this is an object. And this takes in a URL, and the URL is going to be our root node address. So let's add in the root node address within a string using the template string, so backticks, and then the $ curly brace interpolation. And then we want to hit API/blocks. All right, very nice. Now the second parameter to the request function, like a lot of Node.js methods, is a callback function. So let's provide that callback. And this fires when the request is successful, or rather when the request completes, because the request can actually result in an error, which is why the first parameter to this is an error object. Then we have a response object in the callback as well as a body object. Cool. If all goes well with the request, the body field is going to contain the stringified JSON response from the API/blocks endpoint. However, if things didn't go quite successfully, the error object is going to be defined. Therefore, let's make sure to only run code if this error object is not defined. In other words, if not error. We also have that response object, and this provides meta details about the result of the request. For us, the one field that we want to check with this response object is its status code. In the event of a successful HTTP GET request, the status code should be 200 according to the HTTP protocol. So let's also check that the response.status code is equal to 200. So we'll join both checks with the logical AND operator, which is 2 ampersands. And if we make it past these conditions, well, we know that the request was successful. Therefore, let's get the root chain by parsing that resulting body. So this is the resulting root chain by parsing that body that we get from the response by requesting the blocks from the root node address. And then what we can do is we can attempt a blockchain replace. We'll call replace chain with that root chain as well. Cool. And to make this functionality visible, let's provide a console.log that outputs that this replacement is happening with the root chain. We're going to console.log replace chain on a sync with, and then we'll provide root chain as a second parameter so we can see what that root chain actually looks like. Cool. Finally, with this function written, we still need to call it at an appropriate place, and we want to sync the chain right after the application has successfully started. And we can do that within the callback to the listen function. So let's open up a body for this callback. Now console.log isn't going to be the only function called. We also want to call the sync chains method we just set up. So make sure you have that change, and then make sure you have the sync chains method overall. Cool. With all that down, let's try this out and start up a couple blockchain instances. So back in the command line, fire npm run dev for a main node. And what we want to do is we want this root blockchain to have a few blocks. So that way we can start a second blockchain instance as a peer, and then we're going to see if it makes a request to the root node to synchronize its chain right away. Go ahead and open up Postman. Hopefully you still have your API/MINE request configured. If not, head to the body tab. Make sure you have raw JSON application JSON. Configure a data, and then this needs to have double quotes around all of this for the JSON body. And make sure the headers are present as well, that the content type is application JSON. Then go ahead and send the request a couple times. The first time you should see that you have a chain of around 2 blocks. And then the second time, the chain is now 3 blocks, and you keep doing this as much as you want. Very cool. And the idea is that when we start up a second peer, so in the second window of the command line, and when we fire npm run dev peer, well, it should synchronize right away. And immediately we get a bunch of output, and you'll find that it says replacing chain on a sync. Cool, so it's synchronizing with this entire blockchain. Awesome. So we're making sure that now new instances of the blockchain will instantly synchronize with the currently accepted longest chain in the network. And this is a pretty safe situation, since if it just so happens that the root node doesn't have the true longest chain at the moment, eventually an even longer invalid chain will come in from another node in the network, and then either the newly started peer will pick up that, and the root will pick up that anyway to allow any new peers to synchronize right away. Really, the more nodes, the better, and the stronger the network becomes. Cool. Let's move on and make one last improvement to our pub/sub implementation. We're going to get rid of those redundant interactions where it publishes to its own subscriber. In most cases, you don't want to publish to your own subscriber, since why would you send a message to yourself about something you're already aware of? So we're going to get rid of that kind of side effect that we currently have in our implementation and avoid those redundant interactions next.